This set of videos is going to be for March 31st and April 3rd. Excuse me. We're actually going to look at the logarithm function, see how it works, and then see how the graphs of these functions behave due to the normal transformations that we do. Probably 3 videos. First video, we're going to look at just the logarithm function, how we can use it, what it's telling us, and how to evaluate log functions. So I already gave the definition. Hopefully this isn't new, but a logarithm function is really helpful, and we're going to see why. But we can go from what we call an exponential expression or equation. So this would be our exponential here, where a is not 1. If a is 1, anything raised to the 1 is 1, so there's no need. But if we have this equation, then we can actually write the logarithmic equation or function. Here, if we look at this exponential equation, our base would be a. So we would say here log to the base a. What's opposite of our base would go inside of our log function, and whatever is in the exponent goes here. So hopefully we see this in a second, that these logarithmic functions, they're really helpful when it comes to, excuse me, when it comes to needing to get exponents out of our, variables out of our exponents. Whoa, all over the place here. So that's where log functions come into play. Now a few things. We do call this this is a log function. We do call this the log function of base a. So this would be the log function of base a. We're going to see how these functions behave here in a little bit. Here, if there's no base here, it's just log, then what it's understood is that this is the log function of base 10. So if there's no base here, it's understood. The base 10 is used so frequently, especially in physical applications like chemistry and physics, that they just said, hey, instead of writing 10 all the time, let's just call it log. So it's understood base 10 if it's just log. And then here, last class we looked at, if you haven't looked at last videos, please do so. Here we looked at the log function with base e. E we said is a number, excuse me. And if our base is e, we have an exponential equation that we're trying to switch to a log. It's called the natural log function, and we call it ln of x. Now, what this means is if we have a base e, it looks like this. But people don't write this. Again, this is used so frequently that instead of saying log base e, we just say ln of x. People don't say this. They just say ln of x. Excuse me. So now let's see what happens here. I'm going to actually go through a few of these, let you try them, and then I'll put the solutions on the next video if you're trying to check your work. But from our definition here, going from our exponential to log, oh man, my pen just combusted. Exponential to log and the other way around, then what we can do is here, we have an exponential equation, it looks like this, we want to write it as a log. So we can do that and say that this here would be log, our base would be 7, so log base 7 of what's opposite of our base would be 6 equals x minus 2. So the idea is that hopefully you can see where this would be helpful. Here we have a variable in the exponent. So what's happening here, we can use the logarithm. By using that logarithm, we get the variable out of the exponent. Now, if we had a graphing calculator, we could actually put this in to our calculator, get that value, add 2, and solve for x. So this is where logarithms are helpful. And in general, logarithmic functions, like here, if we had an equation that looked like this, you know what to do. Oh yeah, divide by 2. Why? Well, here it's multiplication. Division is the inverse of multiplication. So that's what's happening. Same concept here. If we have a variable in the exponent, the inverse of having a variable in the exponent, the way that we can undo that is by using this logarithm. Now, similarly, if we have a variable inside our logarithm, we can write this as an exponential. We can get that variable out of our logarithm by using exponentials. So here, we could rewrite this. We say this is log base 8, so our base in our exponential function would be 8. Our exponent is always going to be opposite of log because the output of logs are exponents. So we can say 8 to the 15th is equal to, and then whatever inside goes here, 8 to the 15th equals x. I'm going to let you try these next three. This actually can simplify. This could simplify to one value, right? We could actually plug this into even your iPhone calculator if you have it. 8 to the 15th, we can get that value. This actually values to one value too. I'm going to go over that. Well, I can go over that now, real quick. Here, if we want to write this as an exponential, our base here is 3. Our exponent would be -3, and on the other side would be x. Now, based off our conversation last class, hopefully we can remember that if we have a negative in our exponent, we can write that as a positive, and we can say that this is 1 over 3 to the third. If we have a negative in the exponent, we can write that as a negative, or as a positive by writing it in our denominator, and then 1 over 27 equals x. You try the next three. I'll post those solutions on the first part of the next video. But let's go on to see how we can evaluate these functions. So now, how we can evaluate these functions. Here, we're given the log function and an x value. We want to see what the value of that log function is at that x value. So we can say f of 16 equals log base 2 of 16. And now this is going to be really helpful moving forward when we use the properties of logs next class and in 2 classes solving equations. But now we want to try to evaluate this log base 2 of 16. Let's say we don't know what this is, right? We don't know what this is, but we can figure this out. We could change this to an exponential to just figure this out and say 2, let's call it n because we already have an x here. 2 raised to what power n will give us 16. And we can figure this out. 2 times 2 would give us 4, times another 2 would give us 8, times another 2, 16. So because we're multiplying 4 by itself 4 times, n would be 4, which means that here, this logarithm, if we plug 16 into log base 2 of x, then our value would be 4. So the way that we should be thinking about logarithms is our base, we need to think, what power can we raise our base to in order to get to 16? Well, 2 raised to the 4th power gives us 16. I'm going to stop the video here. I'm going to push you to try these 3. Again, I'll post the solutions for these 6 on the next video. So check those out. The next video, we're actually going to see how these functions behave, the key features of these functions, and then on the third video, we'll see how we can transform these functions.